course profile, we will have assignment on week number 6. It will be uploaded to you. Mute your mic, please. Okay. You will be given 5 days to solve the assignment in groups and submit it on Thursday on the SULMS. One of the group will be submit. All information required for assignment, you will receive them from your tutor through the tutorial. The missus will talk with you about the assignment. Okay. Now, what are the distribution for the assessment tools? Let me say, we have assessment 1, which will be test. It will be in week number 9, 30 marks on this test. Okay, it will cover course learning outcome 1, 2, 3. Also, you will have assignment. It will cover 1 and 2. Okay, 1 and 2 and 3. So yeah, sorry, 2 and 3. And finally, you have the final exam, which is 50 marks, will cover the 4 course learning outcome. Here, more information about teaching learning methods, and here is our schedule. Module 1, as you can see here, 24, we started this week. 3 weeks for module 1, which is called vector calculus and matrices. These are the topic for each week. Okay, and how we will deliver them, the activities. This is module 2. Okay, I just mentioned for it, and I will leave you to read this later on, inshallah. And this is our activities. You will have in week number 7 study week to prepare for the let me say assessment 1. And then week module 3 weeks for this one, for first order differential equation, and module 4 for second order differential equation. Revision, you will be given 2 weeks, and on 9th May we will have final exam. Our let me say textbooks you can use or books you can read is Advanced Engineering Mathematics, okay, by Crazy, and the second one is Advanced Engineering Mathematics by Zell and others. Okay. Now this is for the course profile. Let me start with today's topic. Okay, 1 second. You see the slides? The slides?
Yes, doctor.
Great. Great. Okay, so I can write here. 1 second. Okay. Now our first module, okay, is vector calculus and matrices. This week we will discuss vector. Okay, just 1 second. Yeah, vector calculus operations. Okay, which is related to the first course learning outcome, which is determine the vector differential and integral calculus. In this module, we have 1 point to focus on, which is vector calculus operations, where we are going to talk about gradients of scalar functions, directional derivatives, and divergence of vectors. We will solve a problem together. Today, I just want to revise with you what you study related to vectors in semester 1, because I need to remind you, then we will build on this in our topics. You remember quantities could be classified into scalar and vector, and you define a scalar to be the values which have no direction. Okay, example is mass, volume, distance, while vectors is value with direction. I mean, you cannot say, as example, 7 or 8 or million, similar to scalar. You need to say 7 with 30-degree angle, as example. You need to specify the direction. Okay, example of this is acceleration, velocity, force. Usually vector scalar, as I mentioned, you can write here any number. You can write 7 minus 100 million, whatever the number, 3 over 2, all these represent scalar. But when it comes to vector, you need to write value with an angle. As example, you say 33 at 57 degree. You specify the direction. Different way to write vectors. Symbols used for vectors are different. As example here, as you can see, this arrow used to represent vector. It have tail and nose. And here it started from O to the nose, which is A, and written in this way, OA with arrow over there. Or sometimes they wrote it in this way, as I mentioned, OA with arrow in this way, OA with one arrow in this way, OA with line, OA as example with line there, OA with AC. Sometimes they wrote it as one letter, as example A, and they make it bold. Sometimes A with either a row or whatever it is. Sometimes it's written in a matrix form. As example, it's written as X and Y in this way. And so on. Different way used to represent. If you go to the textbooks available on the internet, you will find different ways. Okay, even websites. But simply, we can represent it by, as I mentioned, OA with a row over there. Or similar to this one, A with this sign, which is similar to AC. Each vector have magnitude, which is the length. I mean, the length of this, you see this arrow? The length of this arrow, how many, as example, millimeter, centimeter, whatever it is, represented by magnitude in this way. You see these lines? OA. It means the magnitude of OA. The absolute value here, it means the magnitude of OA. Okay. Now, vectors could, we may talk about vector with 2 dimensions, it means X and Y, or 3 dimensions, X, Y, Z. In 3 dimensions, as you can see here, unit vectors for X, Y, Z. By the way, when they wrote here I in this way, J, K, these are the vector Cartesian, okay? As example, I will be on X-axis, J, Y-axis, K, Z-axis. And it's simply represented by right-hand rule. It means this line, this finger perpendicular on this finger, and this finger perpendicular on this finger, this finger perpendicular on this. So they are perpendicular on each other. And this is related to this rule, related to many applications in different fields. Okay, still revising. As you can see here, example on this rule, you see these fingers. Okay, right hand rule. Now we can use vector rule, this one, right hand rule, to find the vector which is perpendicular on the plane. Okay, this is my plane. Okay, and the vector perpendicular here, we can find it. Just we do what we call it cross product. I will mention for it. You studied this before. It's used also in manufacturing. You see here, manufacturing this screw. Now, magnitude of vector, as I mentioned, if we have vector P, let P be a vector which have X, Y, Z. Directly you will say, okay, this is 3 dimension. Yes, correct. You are right. It's written in this way, X, I with the signal, okay, this sign, plus Y, J with this sign, plus Z or Z, K with this sign. Now you can see X here is I element, Y here is J element, Z or Z here is K element, right? Also, the magnitude for this, the length or magnitude for this vector, OP or P, let me say, as you can see here, is square root of X square plus Y square plus Z square. Got it? So square each one of them, add them, and then take the square root. Very simple, very easy. You studied this before in previous semester. Now, the operation, if we assume we have vector which is A, as you can see here, A1I, it means I element, I1 is I element, A2 is J element, A3K is K element. And another vector B, as you can see, is B1I, B2J, B3K, right? Now, these two vectors are equal only if A elements equal to B elements. It means A1 equal B1. You see here, this is I element A1, this is I element B1, so these should be equal. You see J elements B2 and A2 should be equal. K element here, they should be equal. So when they are equal, we will say the vectors are identical, okay? Equal, they are equal. This is the equation between vectors. Addition and subtraction. If we have vector A, as I mentioned, and B, and we want to add or subtract them, how we do addition and subtraction? We know if you deal with a scalar, if I tell you as example, 10 minus 6, you will say 4 directly. What about vectors? This is for scalar. What about vectors? In vectors, addition or subtraction done in this way. We add or subtracts I element. It means A1, B1, I. A2, B2, J. A3, B3, K. We add them or subtract them. Okay, I will take example later on with numbers, but now I just revise with you the idea. What if we have scalar alpha multiplied by vector B? Then I need to multiply alpha, as you can see here, by each element. I element, J element, K element, right? Okay, let's apply these ideas here. Okay, now you can see there is vector P, which have 5i plus j minus 3k. Okay, and another vector Q, which have 4i minus 3j plus 2k. If he asks me to add them, then the result I will write I plus j plus k. Open brackets in this way. Now I element is 5 plus 4. So I will write 5 plus 4. J element is 1. You see here 1 plus what I have here minus 3. You see? Now K element minus 3 plus 2. Do the math. The remaining is just merit of doing the math. For subtraction, we do the same, but we just change rather than plus, it will be minus. If he asks me to find the magnitude of P, this is P, okay, I will say it is equal to magnitude, it means this way, right? Which is equal square root 5 square plus 1 square, because J here is multiplied by 1, plus 3 square. I forget, I left the minus because we'll go with square, so directly say 3 square. Do the math. The remaining just merit of calculation. Now here he asked me to subtract 2q minus 10p, so I need to multiply 2 by all q elements here, and minus 10 by all p elements, and then add. Easy. So all this already discussed before in semester 1. Now for a product, you have two types of a product. One of them, if we have A and B vectors, as you can see, this is A, this is B, similar to the previous one. There is a scalar product, which is called dot product and cross product. Dot product also they call it scalar product. Why? Because its results or its output will be scalar, value only, without direction. While vector product or cross product is the product for vectors which produce vector. Okay. Now what is the way? Well, very easy. If I multiply, you see here dot, while here cross, as you can see. Dot, when I multiply them, I will multiply I elements A1, B1, plus, there is no I here. J elements, A2, B2, there is no J, plus K element, A3, B3. Do you see any I, J, K here? No, we don't see. For that, the result will be single number. No more I, no more J, no more K. Also, you learn there is another way to find A dot B, is by multiplying the magnitude of A by the magnitude of B by cosine theta, where theta is the angle between A and B. Okay? For cross product, we use the determinant. You may say, okay, what is the determinant? We'll talk about it in matrices in this way. We will put I here, J here, K here. A cross B, then we put A elements below I, J, K. B elements below I, J, K. And then we start do the multiplication. How we work on this? Now have a look. Let me change the color. Okay. Let me start. By the way, we say equal I minus J plus K. You may say, okay, why minus here? I will tell you when we discuss this in matrices. Later on, inshallah, I will discuss this in matrices. The determinant, the story behind determinant, the minus, y plus, minus, plus, minus, and so on. We will discuss this at that time. Now have a look. Now for I, this is I. We will make here this row and this column. What is left? These elements. So we will say these elements multiply I2 by B3 minus I3 by B2. We repeat the same thing. Let me change the color. Okay. I can't change it. Okay, I will continue. So the same thing for the others here. If we go, okay, now I can change. Okay. For J, hide this column, this row. What is left? These twos and these twos, right? A1 by A3, as you can see here. A3 by B3, sorry, A3 by B1, as you can see here, and so on. You learned this in the previous semester, but at the end, don't forget, at the end, you have I, J, K. So it's vector product. Now, after this revision, let me start with my topic, which is vector calculus. First of all, I would like to define del operator. Del operator, which is represented by this symbol in this way. It's called del operator. It's simply applying, del operator is applying this operation. What's this operation say? It say that, what is this? Partial. Oh, we call it partial? Yes, we call it partial. Partial over partial x, I, plus partial over partial y, j, plus partial over partial z, k. Just a minute, what's the meaning of partial here first? Okay, I will tell you. Now, just to remind you, you remember when we have y equal, as example, x squared. When you come to find y dash, do you remember what is y dash? Which is dy over dx. I mean, differentiate, right? You will say directly it is 2x. Okay, that's easy. It's function y, function of x. So it's easy to differentiate. What if y is function of two variables, x and y? Sorry, the function y is function of two variables, y, x and z. It means this way, y equal x square z or z to the power 3. Okay? How we can differentiate? Because here we have two variables, x and z. Here we need to use, rather than dy here over dx, we will use what we call it partial y over partial the variable we would like to differentiate with. As example, if I write in this way, it means he asked me to do differentiation for y with respect to x, keeping the other variables as a constant. How many variables? 2 variables, so z here will be keep constant. So this will be equal. Have a look. This part I will not touch it. Z to the power 3 is keep it the same because we deal with it as a constant. I will differentiate only the variables, which is x, as you can see here. So we will say it is equal to 2xz to the power 3. Easy? Easy the partial differentiation? Clear?
Yes, doctor.
Yes,
Great.
doctor. Clear.
Great. Okay. Now let's use this del in the first operation, which is called gradient. Gradient of scalar functions. Gradient of a scalar function. It means you are going to be given a scalar function with x, y, z as example, and then you find the gradient. Many applications for the gradient, you will find them in different applications, and the procedure is very simple. You are given function as example phi x, y, z, which is scalar. Then we will apply del on this scalar. Okay, it means this is the del. You remember the del? So I just need to write here phi here, phi here, phi here, because phi will be differentiated with respect to x multiplied by I, differentiated with respect to y multiplied by j, differentiated with respect to z multiplied by k. Very easy. This is called gradient. Give example. Let me give example. Let's start enjoying. Okay, have a look here. Let's see this example. He told me, let me change the color. Okay, red. Okay. He told me that if phi equal, here, let me read what he gave me. X square y z to the power 3 plus x y square z square. Just a minute, there is no I, no j, no k. Oh, this is scalar, this is not vector. Great, it's clear. How many variables? X, y, z. This is scalar with the 3 variables. I'm discussing with myself now. What I'm doing is I'm discussing this with the voice. Now he asked me to determine gradient phi. Just a minute, determine gradient phi. It means I will apply del operator on phi. That's it? Yeah. And then he told me that when you finish, I give you point P, substitute this P, where 1, x is 1, y is 3, z is 2. Substitute, I want number. I don't want any more symbols. Now I understand the question. Please make sure you understand the question. What is given to you and what is needed from you. You need to understand this clearly so you can go further and solve the problem. Now this is my scalar value. He asked me here to find del, so I will differentiate phi with respect to x, as you can see, and then with respect to y, and then with respect to z. Let me do it, okay? This is the result, but let me do it. Now, with respect to x, it means these values, I keep them. I don't touch them. I will say partial as example, phi over partial x equal, I will keep them, y z to the power 3 plus y square z to the power 2. I only will differentiate x here and x here. Differentiation of this x is 2x. Differentiation of this x is 1. So the result is this. Easy? Clear?
Yes, doctor.
Repeat,
Great.
doctor, repeat.
Yes.
Great. Now let me differentiate the phi with respect to y. Have a look. I will keep this x square and this z to the power 3 as a constant. This x, this z square as a constant. So I will say partial phi over partial x equal, let me put them, x square z to the power 3, okay, plus x z to the power 2. I will only focus on this y and this y square. Differentiation of y is 1. So here 1, no need to write it. Differentiation of y square is 2y, so I will write 2 here, y here. Easy? We got the second one. Let's go to the third one. Okay, well, let me erase this part. Let's terminate. Eraser. Okay. Now I will use a green pen. Okay. Now for z, differentiation here with respect to z, as you can see here, these elements I will treat them as a constant. Okay, so I will say partial phi over partial z equal x square y plus xy square. Now I will focus on this z. Z to the power 3, differentiation of z to the power 3 is 3z square. So I will write 3z square. Differentiation of z square is 2z. So I will write 2z. Now easy how we apply del until this point. Is it clear?
Yes, doctor.
Great.
Yes,
Great.
doctor.
Great. Now, you remember del, when we talk about del, what we said? We said del is partial over partial xi plus partial over partial yj plus partial over partial zk, right? Okay. Now, partial over partial x, we already got it. This part. I will take it and substitute it here. Partial over partial y is this part. I got it. I will take it and substitute it here. Partial over partial z, I got it. I will substitute it here. You see, I substitute the first part by I, the second part by j, the third part by k. I completed half the solution. The next part is he gave me this point. He told me after you find the gradient, substitute at this point, show me how much the gradient at this point, where the first number is x, the second number is y, the third number is z. Got it? So I will come to substitute. Here, 2, for x, I will use 1, for y, I will use 3, for z, I will use 2, and so on. Now, the remaining is merit of math. 2 comments I have here. The first comment is, see the gradient, what it gives me, scalar or vector? What do you think?
Vector.
Excellent, because we have I, j, k. Excellent, I, j, k. So it gave me vector. This is the first comment. The second comment, see how I use brackets here? Use brackets is free, okay? Use them, because here you have many numbers with different powers, many mistakes coming from our students in the past, coming here in the calculator. They know how to write, how to multiply, how to take power for something, but the problem, many numbers, they work in rush, so they get mistakes. Please make sure you find the final solution correctly. It is your target. As example, if you find this 84, 32, but here 78. This is something wrong. This is not what we are looking for. It was 72. You make it 78. So make sure you make it correct. Now, let me back to the example. Let me back. You see the example here? He asked me to find the gradient. He gave me here scalar function phi, and he asked me to find the gradient, and he gave me point. I started with differentiation partial derivative, as you can see here, for x with respect to x, with respect to y, with respect to z. Then I substituted here, as you can see. Okay? And finally substitute for the point. Do the math. Now, this type of a problem have a procedure. You remember we started with differentiation with respect to x and then y and then z, then substitute, then Now, if this is exam question, what do you expect the difference? The same procedure. The difference coming here, in these values, Number will change, symbols will change, power will change, but the procedure is the same. The same procedure. I will show you. This is exercise for you. I want you to solve it. I change here the variable powers. I keep the point. What I want you to do is to find the gradient. I gave you a hint here. Do the differentiation with respect to x, with respect to y, with respect to z, and put it here, and then substitute for this point. You need to find these results. What I want you to do in the next few minutes, I want you to start solve it. Home finished. You finish? Ladies, gentlemen, do it on a paper. Bring a piece of paper and pen and let's work together. Are you still with me?
Yes, doctor.
Great. Work on a paper. I want you to practice. You will solve more problems in tutorial, but for the time being, let's solve at least one problem here. Just this problem and we will close the session. Just this problem. Okay. While you are solving, let me also try myself. This one, I will differentiate. I'm thinking with a voice, with x, with respect to x, so I will say 3x squared. I will keep y and z plus differentiation of x is 1, so no need to write. I will keep y and z. Y, z to the power 3. Okay. Now the next one, differentiate with respect to y. So I will keep x to the power 3. Y, differentiation of y is 1. And I keep z as a constant plus. I keep x as a constant. And then 2y, then I need to differentiate y squared, it will be 2y. And z to the power 3. Last one, I will keep x to the power 3, y also, only differentiation z will be 1 plus x, y squared, differentiation of z to the power 3, it will be 3z squared. You see, I'm following the procedure. It's very easy. It's very easy. Just follow the procedure and try to find the result. Okay. You need to practice. It's like any other sport. You need to practice to get, they say no pain, no gain. You need to practice to get the experience. I gave example, I explained it, you understand it. Now it's time for practicing. I want all the time when you come to the live session in the theoretical part to bring piece of papers with you, pen, because you are going to be given example to exercise to solve. And then we have sort of discussion. Now, till this point, is it clear?
Yes, doctor.
Do you have any question? Do you have any question?
No.
Okay, I will try to upload the video, the recorded video record, okay, in two parts. I will split it in two parts as usual and upload it to the SULMS. If you want to listen to the live session later on, you can easily listen to it, okay? And we will continue building on this, okay? In the first two modules, we only focus on vector calculus. We will see the applications, the process, the operations, and so on. So if you don't have any question, have a nice day, the remaining of the day, and looking to see you next Thursday. Okay? See you. Take care. Bye-bye.
Doctor.
Yes.
Doctor, could you please add me to the Microsoft Team class? Because I'm not...
Just send me, drop me on the Microsoft Team message, and I will do it after I finish, okay?
Okay, because you added me at the group.
No problem.
Tutorial.
No problem.
I will add that. Okay, thanks.
Okay, just drop me a message. I will add you. Okay.
Okay.
Have a nice day. Have a nice day.
You too, doctor.
Thank you very much. Thank you.
Thank you, doctor.
You too. See you. Bye bye.